Second, regarding what you mentioned, that humans have adapted and are different from apes. This is a very interesting question because, from the perspective of our DNA, we are different by 4 to 5% from apes, from chimpanzees. But notice what a leap that is. I say, okay, for cell phones, depending on the model, different amounts were used. Now, up to 200,000 patents are used. Let me put it this way. If chimpanzees differ from us by a mere 4%, and you say that is just a result of gradual evolution, then let us try to find modern cell phones in which the ape contributed not just 200,000, but perhaps 180,000 of the original patents. This would truly demonstrate the small gap you are suggesting exists between our two species.
But why would an ape need to create a phone?
Well, exactly.
That's evolutionary.
Look, let's put it this way. There's a chicken. Roughly speaking, it shares 30% similarity with humans, mainly in terms of cellular functions. And it has the ability to create, so to speak, the ability for creativity. It can build a nest.
Right?
Then let's take the next closest. To us, that's the chimpanzee. Its similarity is not just 30%, but already 95 or 96%. But it can't create anything more than a nest. Still just a nest. And suddenly, just a difference of 4%, and bam. Nuclear power plants, skyscrapers, space stations, cell phones. Evolution is supposed to be gradual. Gradual adaptation happens, let's say, one gene changes, then another gene changes, and you slowly, little by little, adapt and improve. Evolution is not a revolution. Evolution is a gradual process. But when we talk about going from a chicken to a monkey, the same nest, and then suddenly, bam, everything changes,
But why compare them? They're completely different creatures.
that's exactly what I'm saying. Welcome to our club. In other words, you start to think about it, that really a chicken is just as different from a human as a monkey is? Very much so.
Transitional forms. For example, take Neanderthals or Australopithecines. There's something in between humans and monkeys. That's exactly the transitional bridge.
A transitional bridge. By the way, that's also a very interesting question, these transitional bridges, because I have already brought up the specific example of the bacterial flagellum. And the researchers claimed in their findings that they discovered what they believed to be a transitional evolutionary form, where instead of a full flagellum, there is actually a needle, where several components exhibit striking similarities and other related features and so on. And at first, this idea gained traction. Even in court, they said that no, there's this concept called irreducible complexity. They said no, since there is this transitional flagellum. So it turns out that irreducible complexity doesn't hold up. But then here's the funny part. After the trial was over, it turned out that this wasn't a transitional part from simple to complex, but rather a degradation of the flagellum. Later, based on age and mutation density, it was discovered that these organisms with a flagellum, where the flagellum is used as a motor, like a propeller, a bacterial flagellum, it's the original version of the tool, and from it came a much more simplified and mutated variation, where it's essentially nothing more than a standard everyday simple needle.
Right? But that's evolution too. It's simplification. Like with humans and apes, that is, again, we lost our hair, we lost our tails, we lose tendons because we no longer need to climb trees. We lose, well, all vestigial features. So it's the same story with flagella. They become simpler because you don't need to be such a complex structure just to survive.
No, the function of the flagellum is very important for bacteria. It makes it much easier to find food. This is definitely the next step in evolution. If it stays in one place, it's much harder for it to find food. The food has to come to it. But this way, it can search for food itself. That's absolutely true. But the nuance is, what are we talking about here? Evolution exists. One form appears, then a more complex form, then an even more complex form, and so on. And that's how it emerges. New functionality. But in reality, there are no such facts. On the contrary, there are. And there exists complex functionality like this flagellum, the bacterial flagellum, which is used for movement, like a propeller. And all these transitional forms, it turns out, do not go from simple to complex, but on the contrary, from complex to simple. In other words, there is degradation but no development. Once again,
Well, this degradation is actually the key to development because it's about getting rid of what's unnecessary.
well, effectively getting rid of what is completely unnecessary. And once again, we see that bacterial movement is actually very necessary.
So by degrading in this direction, bacteria can't move.
Yes, they just exist as they are. And wherever they're carried, that's where they go. They can't move toward food, that's for sure.
So there's simply no need for it.
Well, you understand. Once again, let's be honest. There's no need to force things, we need to be objective. You're saying that the ability to move in search of food is unnecessary for bacteria. I'm saying that's nonsense. Of course, it's not unnecessary. It's essential. It's the next step in evolution. A more complex combination of protein molecules gives rise to new functionality. That's real progress. There's a big difference between those who don't have flagella and those who do. It's a major leap forward. The complication of the molecule, the complication, let's say, of the informational code, leads to new functionality that is useful. According to the new evolutionary model, this is exactly the driving force.
But is increasing complexity always the path to progress?
You can't just insert 1,000 elements into the code. Artificial intelligence, image recognition, and banking systems.
Well, is it really appropriate to compare, say, computer code and bacterial code?
Well, not only is it appropriate, it's simply a fact. If we're talking about machine code, the most common is binary code, 0 and 1. But there are specific types of computer architectures that allow you to use up to 8 individual units, or even as many as 48. So, it's kind of like a fundamental alphabet on which the entire code language is written. From these basic building blocks, complex phrases, sentences, and functions are meticulously constructed and organized. There's a specific sequence. For example, I could take a bucket of letters and dump them out on the pavement, but that wouldn't create a Pushkin poem.
There is a chance that it could happen. There's always a chance. It's not zero.
There really is a probability. And the most important thing is that it's calculable. You can actually calculate this probability. In this case, if you ask GPT right now, it'll give you a number with about 38 zeros per year. That's how many living beings there are. Well, multiply that by what, 4 billion years? That's for Earth, for example. Let's assume that living beings appeared right from the very beginning, right from the very start. Let's give it a head start, really give it an advantage.
That's a very rough margin of error.
Because we need to calculate how many transmissions there were. After all, we need mutations that are passed from one generation to another. That's why the number of organisms involved in this evolution is important to us. So if you multiply by the duration of Earth's existence will add another 12 zeros, making it around 50. I have read articles where the goal was to evaluate to the maximum. At the maximum, there is simply a maximum, that it can't go any further. Because at a height of 1 meter, let's say, bacteria will no longer be able to exist below. And in this assessment, the quantity, zeros. That is 10 to the 64th power. What am I getting at? This is the number 64. Zero. These are tiny numbers. 64 or 32. They have virtually no significant impact on the overall probability. Because if we start calculating the complex probability of assembling, say, a worm genome, then we inevitably arrive at it. 0, 0, 0, 0, 0, 0, 0, and several hundred pages of zeros. You say there are not 64 but 32. Well, from the end, remove those 4,000 zeros, remove 32. It's absolutely nothing. It makes no difference. That's the point. The molecule itself, anyone will tell you now, the molecule itself. This sequence of 4 letters which creates information, not gibberish, not nonsense, but actual information according to which we have eyes. That's exactly how they function in this spot made from the same materials just like our heartbeats. All the information is encoded in DNA. This is probably already written in school textbooks. And this information is very large, very complex. It turns out that the lifetime of the Earth, even the universe, isn't enough just for it to appear. The probability isn't zero. That is, it's possible it could happen by coincidence, yes. But the probability of these things, in other words, their improbability, is greater than a miracle. So if you believe in this, you believe in science fiction, miracles, and fairy tales. And faith, I believe in 99.99%. This is not proof of percentages.
No, okay, but faith is not miracles, not fairy tales, not fantasy. In
In this case, you and I have changed places, see? You believe in fairy tales now.
what fairy tales?
You believe in the possibility that something might happen. 0.000000000.
No, well, everything appeared from one molecule, so to speak.
Where does the information come from? Dialogic?
A molecule simply formed from elementary particles under the necessary conditions. That is, the conditions were met, the molecule formed, and from there development began, a geometric progression.
I'm telling you this. What I am asserting here is that in the field of science, there is absolutely no established scientific model or framework for describing the sudden emergence of complex biological living organisms from inert, non-living matter. That is to say, from the purely inorganic. Life somehow appeared. That is, life did not emerge from stone and sand or chemicals. There is no such model. Zero.
Everything in the world consists of the same atoms. Conventionally, a person is just a large assembly. carbon, hydrogen, oxygen, and nitrogen.
Well, in a sense, yes. Let me say it again. Obtaining the nucleotides themselves is not an easy task. Right now, it is possible, but only under laboratory conditions, in sterility. But that's not my main argument. The main argument is not that these nucleotides appeared, and in unlimited quantities. I'm talking about the fact that they have to be arranged in a specific order. Let me say it again. Imagine you have a bucket of letters. Yes, these are chemical elements. Let's say they're written on pieces of paper, written in ink, all that. It's hard to get them. But let's suppose there's some kind of random generation happening somewhere. I can't believe that, but fine, I'll go along with it. But now comes the second task. From these various buckets of letters, we need to meticulously assemble and compose a complete literary work by Dostoevsky. This collection contains approximately enough individual books to make up about 2 full meters of printed books on a library shelf. We need this kind of information not for a human, but for an ordinary earthworm. A worm. A primitive creature. Just a primitive. The most primitive living being. A worm.
All right, let's sum up. Which theory do you adhere to? The creation of life? I'm curious about this.
Once again, this is not just some guy.
I understand. I see a person with experience in this matter.
There is an entire field among scientists who think the same way. They say there is, some call it an agent, an author, some call it the great programmer. It doesn't matter. There is still a creator. Not by chance, not from chaos, but there is a creator.